need to quantify the adsorption. I need to quantify the adsorption. Okay, he has taken poison. How much I have to give? I need to quantify the adsorption. For that, we have a term called adsorption isotherms. We will quantify them by drawing a graph. We are going to quantify the adsorption process. Whatever the process of adsorption is there, this adsorption process is quantified by drawing a graph. So for the graph, I have y-axis and x-axis. Some components should be keep here. What are those components that we are going to try to see? So I can directly say keep this here at constant temperature over. This is called adsorption isotherms. No, we will try to see. So I have a charcoal particle. I have a gas molecule which is sitting at the charcoal particle like this. Okay. So I want to quantify this. How to quantify this? What is the amount of gas adsorbed per unit mass of adsorb? I forgot this. The thing which is adsorbing is called adsorbate. The thing which is adsorbing is called adsorbate, and which it is adsorbing is called adsorbent. Remember this, bait and bent. What is the amount of bait per unit amount of bent? What is the amount of bait per unit amount of bent? That I need to quantify. How will you do is amount of bait per. If I say per, you need to divide it. Unit amount of bent. Sir, why you are saying unit amount? One thing should be constant, na? Any one thing should be known for us. So I will give known amount of charcoal and I will observe how much unknown amount of poison is going to adsorb on the known amount of charcoal. I can quantify like that. So one thing should be known. So we don't know how much is going to adsorb, but what we know is how much we can give, the bent. So amount of gas adsorb or chemical adsorb per unit mass of adsorbent. So this is one thing. Okay, unit mass of adsorbent. This is one thing which should be taken. Where, what, you tell me. Okay, on x-axis or y-axis. Next, for this thing to happen, let's say I am talking about gas. For this thing to happen, if I take charcoal and I will keep charcoal here. You are not breathing. You think gas will adsorb? No, you are not breathing. For that, you need to create a pressure. If you create a negative pressure, then only all the gas will come here. So if I keep charcoal here in the air, I need to increase the pressure. Then only it will adsorb. Or increase or decrease. Something I have to do. Then only it will adsorb. See, if I keep charcoal here, whatever the gas here, it will adsorb. What about the gas which is present at the corner? How it will adsorb? For that, I need to increase the pressure. So another point is pressure. If it is gas, if it is poison, in that case, what is the concentration of poison? More concentration of poison, more will be adsorbed. Less concentration of poison, less will be adsorbed. So this or this. Now I kept charcoal here, unit mass of charcoal. Okay, I am increasing pressure. Which is known, which is unknown here? Which is known and which is unknown here? Among these two, which is known? I will tell you once again. Listen, I will keep charcoal here. Gas is not adsorbed. I keep charcoal here. Slowly I will increase pressure. Which is known, which is unknown? This is charcoal. What about this? You know this one? Then how you are saying it is known? This is known. I increase pressure. I know how much pressure I am increasing. So pressure or concentration on x-axis. I told you, known thing take on x-axis. Unknown thing take it on y-axis. Whatever you are doing this experiment should be done in constant temperature. Sir, why? If you increase temperature, adsorption will decrease. Temperature increases, it will decrease adsorption, because I am talking about physical adsorption, because this temperature will break your van der Waals force, which are responsible physical adsorption. See, this chemical is adsorbed to charcoal physically. While adsorbing, it is forming van der Waals force of attraction. They are weak forces. If you increase temperature, that weak forces will be broken. So, whatever the experiment you are doing, do it in a constant temperature. Sir, which constant temperature? Depending on where you are doing experiment, where you want that. If you want your adsorption of poison and charcoal, what should be the temperature? Adsorption of poison and charcoal, what should be the temperature? Constant temperature. What the temperature should be? Body temp. Very good. Body temp. Where you are targeting it? Body temperature. If it is a chemical in the mask, in that case, room temperature. Where you are going to work. Okay, remember this. So, where you are going to carry out the experiment, that what you are going to keep the temperature. These are called adsorption. Iso means same, therm means temperature. Adsorption isotherms. Okay, now you define it. Adsorption isotherms are graph plotted between amount of gas adsorbed per unit mass of adsorbent on y-axis, pressure or concentration on x-axis at. That's it. Same definition is given in textbook also. So, we defined it. So, that's what I want you to learn like this. If you had, it will be waste. How we learned it? I created it from the basics. So, basics are very important. Okay, learn it from basics. Now, there are two people. Adsorption can be happen in two forms. One form of adsorption is monolayer. This we call it as monolayer adsorption. This we call it as multi-layer adsorption. So, to explain monolayer adsorption, two scientists came forward. To explain multi-layer adsorption, three scientists came forward. Okay. One is Freundlich adsorption isotherm. One scientist is Freundlich adsorption isotherm, and another scientist is Langmuir. Not Langur, okay? Langmuir. Langmuir adsorption isotherm. To explain the multi-layer, three scientists, Burnett, Emmer and Teller. Okay, so three scientists, bet, we call it as a bet, and they created an equation, and we call it a bet equation. So, explain the monolayer adsorption, Freundlich and Langmuir adsorption isotherms, and multi-layer we have bet equations. There we don't call bet adsorption isotherm, we call it as a bet equations. Okay, remember this, don't forget. Now, we will move on to Freundlich adsorption isotherm. Actually, this is the topic which I have to teach today, because I saw so many people, so I repeated once again. Listen, we will first see the theory, concept, then we create the graph. Graph can also be created. See how it is. So, slowly I increase the pressure. Okay, slowly I increase the. Initially, when I keep that charcoal in the air, few gas molecules will adsorb. Without pressure, only few gas molecules will adsorb. Without pressure, because whatever the near gas molecules are there, they will adsorb. To increase more adsorption, I need to increase the pressure. Slowly the pressure increases, amount of gas adsorbed also increases. After one point, there will be no further adsorption because they form monolayer. There is no further adsorption because there is no place to sit. There is no place to sit itself. So how to represent this in graph? Because I am talking about gas, so I am taking pressure at the x-axis. Okay, I am talking about the gas. Now tell me where to start it. You tell me how to start the graph. Initially, at zero pressure only, we have some particles adsorbed. How to start this? This is the concentration. At zero pressure, there is already some concentration. So I should start graph from here. Remember this. Where to start this graph? Okay, I should start graph from here. Slowly increase the pressure. The amount of gas is also increasing. Slowly increase the pressure. Amount of gas also increasing. After the monolayer is formed, what happens? Even though increase the pressure, there is no increase in the amount of gas. How to represent that? Straight line. That's all. See, no need, you won't forget this graph. If you know the concept, you can draw the graph. Okay, I explain once again. Initially, we have few molecules of gas adsorbing on the charcoal without increasing pressure. How to represent this in the graph? This what? This gap indicates at zero pressure already we have some concentration. Increase the pressure, amount of gas also increases. See, pressure here x-axis is also increasing, y-axis is also increasing. Increase the pressure, amount of gas adsorbed also increases. Once it forms monolayer, then there is no further adsorption. So it is becoming almost flat. Slowly increases and it will become flat. That's how we represent. This is your Freundlich graph. Okay. What Freundlich says is amount of gas adsorbed per unit mass of adsorbent is directly proportional to pressure. Now we create equation now. Because see, pressure is increasing, gas also increasing. Okay, it is directly proportional to pressure. Remove the proportionality constant. What will you keep here? Constant is equal to Kp. Keep some constant. There is another constant which to be kept like this, 1 by n. N is also a constant. Okay, that K and N will vary. If you take charcoal, the value will be different. If you take silica, the value will be different. If you are changing the adsorbing species, the value will be changed. Now, sir, I want to know, I already have charcoal with me. I want to know the N value of charcoal. I want to know the K value of charcoal. How, sir? How to know this? From the graph. If the graph is curved, to make it straight, what should you do? Apply log. Apply log here. Log x by m is equal to log k plus 1 by n log p. Is it visible there? Okay. 1 by n log p. Draw the graph. X, p is x-axis, log p, n is m. See, y is equal to mx plus c. Wherever x is there, next will be m. The another thing will be c. This will be y. Draw the graph. So log x by m, log p. Should I start from the 0? No. This will be your graph. Okay. Now, see here. Tell me the coordinates. What is the slope? 1 by n is slope. I written there. See, m is slope. 1 by n. What is intercept? Log K. I know X value, I know M value, I know P value. From the graph, I can find out K value and N value. This is your Freundlich adsorption isotherm. Okay, this will be your Freundlich adsorption isotherm. Okay, I explain once again. Listen, don't write, listen. First listen here. Initially, few molecules of gas will be adsorbed on the charcoal without increasing in pressure. That is represented by this gap. Whatever gap is there, so at zero pressure, some concentration is there. This indicates concentration only. Amount absorbed per unit mass of adsorbent. As the pressure increases, the amount of gas adsorbed also increases. Increases. At particular point, monolayer is formed. No further adsorption because there is no place to sit. All chairs are occupied. So it will become flat. So we create an equation by seeing this. How we created? Amount of gas adsorbed per unit mass of adsorbent is directly proportional to pressure. Remove the proportionality constant, keep some constant, K and N we kept. This K and N will change if the adsorbing species, or you can say what is it, adsorbent changed. It will change. So I want to know what is the value of this adsorbent. For that, what should I do? I should apply log. If you apply log, the curve will become straight. Remember, okay, in your life, if anything is going in curve, apply log. Okay, I don't know how you apply log, so apply it. If I apply log, the curve will become straight. I will tell you why that also. If the value is this much big, then it will curves. When you apply log, what is log? Log is decreasing the value. 100 log is 10. Means what? 100 became 10. Then the curve will become straight. That's what the logarithm is. Log, what is log is? Log is compressing. If you take base 10, so 10 square, that will compress 2. Okay, like that. It will compress. If you take base 100, more compression. Base 1000, further more compression. Depending upon your values, you apply log. Okay, because your teacher said apply log, you apply log. You don't know what is log and everything. So what log will do is, it will compress the value. Log will compress the value. Okay, that is the reason, see in the textbook, you have this experiment. While you are doing this experiment, what you will do is, you will take log x by m plus 3 or plus 4 something. If you take plus 3 here, you need to take plus 3. After applying log, after compressing, again you will add 3. Because it is so much compressed, you can't draw the graph. For that reason, you will take plus 3 here. Plus 3 or plus 4, depending on what is there in your record. Okay, but as per textbook, it is plus 3. Plus 3 or plus 4 you can take. Means what? After compression also you are increasing the number. Because it is so much compressed. Hence you are increasing the number. There is experiment for you. You will take charcoal, you will take acetic acid. You add known amount of acetic acid, then you add 1 gram of charcoal, then you equilibrium it, keep it aside. While doing this experiment, if you touch that conical flask like this, heat will be transferred, gone. You will get wrong. Then you say, sir, experiment is not good. You are scolding, all the chemicals are expired and all things. So you will do the mistake there. Be careful. It is a isotherm. That experiment should be in constant temperature. If you are holding conical flask through its neck, hold it through its neck only. If you are holding like this, throughout the experiment, you should be like this only. Okay, and your body temperature should not change. It should be constant. How you will maintain, I don't know. You should not talk, you should not move, you should not be like, you should be like this. Okay, so you will do this experiment, do it. That's what I am saying. Theory, if it is one part, into 3, into 4 is practical. There you learn more compared to here. This is what I am teaching theory, but in practical you learn more. Okay, so we apply log. If you want to apply log for this equation, we get this equation. Draw the graph. You will get this. Okay, that what is your Freundlich equation. Next class we will try to see what is Langmuir adsorption isotherm.